So x minus p.
X minus p is that vector. Fine. So x minus p is that vector. Fine.
So
Carry
this
on.
this will constitute our domain for the map.
What will constitute your domain?
So all the vectors of this form x minus p, like all the vectors of this
All
form
the
from V.
vectors of the form x minus p, such that where are x and y, x and p coming from?
So U, the open set U.
Now you see that if you consider them x and u, sorry, x and p coming from u, is this a vector space?
So if it's an open interval, then it's a vector space.
What is an open interval? See, we don't have open intervals here, we have open
So
sets.
it's an open set, yes. If it's an open set, it's a vector space.
Why?
So because
Because
the
you see that this vector is here, this vector is here, this vector is here, but if we continue in this direction, this vector is not in u, right?
no sir,
Right. So
no sir.
suppose this is y. Okay, this was p. So what is this vector? This vector is y minus p, right? This vector is y minus p,
Yes sir.
right? Now if y minus p is an element in any vector space v, then we also know that for any lambda, lambda times y minus p is also in v,
Yes sir.
right?
Yes
Fine.
sir.
Now, are we taking only x minus p's or x minus p in u?
So x minus p in U.
Then it is not a vector space.
So 1 second. So x minus p as in x and p belong to you, but x minus p in that we did not belong to you.
Yeah, but if you are restricting yourself only to x minus x and p's in u, even then, if x and p's are coming only from u, then you see lambda. So this vector, see, if y minus p has to be here and this thing has to be a vector space, then for any lambda, lambda y minus p should also be here, right?
Yes sir.
By definition of a vector space.
Yes sir.
Now you see, what is this? This is lambda y minus lambda p, right?
Yes sir.
Now you see that neither lambda y nor lambda p are elements of u if lambda is chosen properly,
Yes sir. Yes sir.
right? So
Yes
p
sir.
is this vector. If you choose lambda to be 2, then lambda p, which is 2p, will be here, which is outside u, right?
Yes sir.
And similarly, x is here. So if you choose lambda properly, say twice x, that would be somewhere here. So that's what I'm saying, that these things are not necessarily in u in that case. You're going in the
Yes sir.
right direction. You're going in the right direction. You're thinking in the right terms, but you have to figure out what the domain should be. If I get a matrix as a derivative, then shouldn't the matrix have a domain and a codomain which are also vector spaces? The answer to this question should be yes.
Yes
Now,
sir.
what is your job is to figure out what is a vector space here, somewhere hiding, also a vector space hiding somewhere here, and what exactly is the matrix. In this case it is easier to figure out, but in this case it is not so easy to figure out what would be the matrix, what would be the vector space, both in the domain case, in the codomain case. These are not things easy to guess for this. That is why we started with the easiest possible thing. We gave this analog and we saw that it is very easy to figure out whether it is differentiable or not, what is the derivative, and then we came right to that situation. You guessed here that this map is differentiable with derivative a itself. Now what you have to figure out is what is the domain vector space, because if it's a matrix it has to have a domain vector space and a codomain vector space. What are those in this case, firstly, and then can I extrapolate that understanding here. So today it's very noisy, and I have to stop here. So let's finish with these questions, especially these two questions, and also think about this situation in more details. First question is, when when is f differentiable at x? Here we have seen a situation when f is differentiable. When we say f is differentiable, when the error term, this is the error term, right? So when the error term vanishes, right? When do we say f is differentiable? When the error term like this vanishes. That means this limit of this quantity, h tending to 0, goes to 0. That is the error vanishes, right? Now, what would be the right formulation of the differentiability of f at the point x in this manner? Think about that. And here in this very expression, you had a derivative present, right? When you will think about the first question, you will understand that conceiving a derivative f prime x just like this is not so straightforward. It is similar, but it is not so straightforward, because you have to understand what kind of an object f prime x is supposed to be. If we have to extend this definition in this situation, in this case, firstly, what would be the definition, first of all, and in that definition, what is this quantity? So think about these things, and reference books. I will mention Rudin's Rudin Elementary. I don't remember the title, the name of the book. Principles of Mathematical Analysis, I think. Okay, Principles of Mathematical Analysis. This is a book from McGraw-Hill Publishers, I think. I don't know now which publishing house it comes from, but it used to be McGraw-Hill Publishers. The other book is Apostle. This used to come from Narosa. Okay, so this book is called Mathematical Analysis. Mathematical Analysis. And this used to be published from Narosa Publishing. And another book is called, it's by Spivak. I think Michael Spivak. It's
And if
called,
you can type it in the chat box, then it will be of great help.
sorry? Oh, okay, fine. Okay. I'm not writing the titles, I'm just writing the initials. Principles of Mathematical Analysis, I think you will understand. Then mathematical analysis. And then Michael Spivak, I think. This is called Calculus on Manifolds. Okay. So these are the three books which will be the primary reference. So there are many other good textbooks available. You can see any book you're comfortable with, but largely we will be following Rudin's book, Supplement results with apostles, theorems, and propositions. And for certain things, we will go to Spivak's book. But there are many other good books. I will tell you some at a later point. Okay, thank you. And please have a discussion on these two things I asked you. One is whether we can postpone the class to 5:30 if it is possible for you. The other thing is whether we can have the Friday class on Wednesday. Okay, so is it possible for you to let me know by tomorrow? In that case, we can have this week's class itself on Wednesday, if it is possible for you.
Okay, sir. We will discuss and let you know.
Okay, so please try to let me know by tomorrow. In that case, I can continue from this week itself.
Yes, sir.
Okay, thank you.